Good morning, everyone. This is DMM working group. We are chair of this working group, Sri-san and Satoru.
Thank you. Welcome to the DMM working group. Few things. First thing, so this is the IETF's IPR statement. Please be aware of the IETF's IPR rules, right? Specifically the restrictions listed in section 5 of RFC 3978, 4748. Make sure if any disclosures that you need to make, please do make the IETF disclosures, IPR disclosures. The other references, please be aware of these specifications. And this is the IETF Note 12 statement. Please understand that this meeting is run under certain rules and code of conduct. As a participant, you're required to comply to these rules. And please read the relevant sections. Again, if you're by participating in the IETF, you're agreeing to follow the IETF process and policies. Please, these are the key things. I think a few things before we get started. Blue sheets. This is no longer relevant. Note takers. I think kindly Carlos has agreed to be the note taker. Carlos. I don't see Carlos.
I'm here. Can you hear me?
Carlos? Is that Carlos? Yeah. Oh, okay. All right. Thank you.
Yes, I'm remote. Okay. Thanks.
And we need one more note taker as a backup. Anybody? Any volunteers? John, can I request you, please? Sure. Appreciate it. Yeah. Thank you so much. Carlos and John are the note takers. And a few things. These are the links to the IETF DMM working group. The agenda is again pointed to the agenda. And a few quick things. The status of the working group documents. The segment routing IPv6 for mobile user plane was ISG has approved the document for publication. Congrats to the authors, to the working group, our area director, Eric Klein. A lot of efforts went in from everybody. Thank you so much. Thanks for all the efforts. It just took 3 years, that's all. So next is mobility aware transport network slicing for 5G. We are going to hear an update on that. I think as I recall, we took few action items in the last meeting, but looks like we didn't see, either we as a chairs also probably didn't follow up, but we haven't seen much discussions on the mailer, but we need to close this work very quickly. I think document appears to be in a mature shape. The user plane protocol and architecture analysis, I think, again, no progress. And is it presentation?
Discuss among the course and what's the next one.
Okay.
Sorry. In terms of the analysis draft for 5G user plane protocol architecture, so we also need to discuss for what's the next step.
Okay. So, but if I think most likely looking at the status, it may be taken off from our radar. Uh, but again, that we need to discuss with authors before we say anything. Uh, today's this agenda, I think first on the list is on the mobility aware transport network slicing. John, you are going to present this.
Okay. 1 second. Good morning, everybody. So I don't think I will probably need all 15 minutes, but I'll try to, from the last meeting, we haven't made updates on the whole draft itself. So I'll give you a recap of where we are and what we need to do with this, with regarding to this draft. So if you'd go to the next page, Sri, please. Yeah. So this is what we had done between the version 04 and 5. There were some significant updates to address the reviews and comments that we had received in this group, and also from comments from a few people in T's. So essentially, we revised the terminology throughout to align with T's framework. You'll see that in the subsequent slides. And also the concepts in terms of the terminology and also the concepts that they were using. And we're also referencing the right documents from T's. So that was one of the major set of updates that we had done to comply with the comments. The other one was to address in relation to 3GPP functions and to be sure that we are not working on anything in the 3GPP scope. So we've made a few revisions. It was never the intention, but we've made a few revisions to clarify that no function in 3GPP is affected. It's only on the IP transport plane. And then I think we're also collaborating with the T slices authors, and those are the broad set of things that we have done. The next page, please. Yeah, I think the next couple of slides are getting into more of the details. You can see that when I said there were significant updates, everything from the abstract to the other sections have been updated to align more with T's, make it complementary to the different methods by which the transport slice can be handled. In this case, the slice that we're looking at is when there's a network in between. You'll see that in subsequent slides. And so it is complementary to the other ways that T's also handles transport slices. So we'll have a complementary set of drafts. Here you can see the changes in names from, we were using SDN controller and so on to what T's uses now in terms of network controller and the TNO, the orchestrator function. So, from figures to terminology and concepts, we've updated. The next slide. Yeah, I think here you can see the concepts in T's being applied here. If you look at the figure on the right, which shows the CE and an AC and attachment circuit in between the each of the 3GPP functions, which are the CE and the customer edge and the provider edge. Those are all using T's functions, T's terminology and concepts. And here we also clarify about the 3GPP aspect of using UDP port. It's only for the transport connection, and the 3GPP part has to be defined somewhere else, somewhere in 3GPP. So that's also clarified at the draft. And I think the next page, please. I think this is pretty much what we've done. I think all the comments that have been raised in this group or any others that we have received offline have been addressed. So I think we would like to request for more working group reviews and proceed to a last call on this.
Satoru-san, yeah.
Good morning, Satoru from SoftBank. I'm trying to review this document, but it's really hard to me because I'm really confused because the most big thing is the context is unclear. So title says, I forgot which one is which. T, transport aware mobility. Some part of the draft say, but other things is mobility aware transport, which is the target, which is the context of this draft. That's what I'm confused. That's why I'm confused.
Yeah.
One thing, and another thing is you define the mobile MTCN number using the UDP source port for the GTPN cap, but you adopt the CGPP defined data model for implement MTCN, but the default model in the CGPP is the logic interface ID. It indicates the interface, but what you say in the draft is MTCN is UDP source port. I don't think it's be interface because it's UDP port. So why you adopt that interface model in the CGPP to reflect that context ID? That's the main reason I confused during my review.
Thank you. I think very valuable comments. I think there's a lot of depth to both of those, and I can take it offline and discuss with you the details, the transport mobility versus mobility of the transport, and also the interface. Maybe, we can decide, if it should be closely tied to 3GPP or we make it more generic and 3GPP becomes just one application of it. So, I'd be happy to discuss and see where the working group wants to take it.
At least we have to discuss whether the UDP port be implemented in the interface data model or not.
Okay. Yeah. Thanks.
So John, can you make sure you go through the document one clean, editorial thing?
Yeah.
And then address some of this.
I will address these comments.
Okay.
Kenji's China Mobile here. The last slide, I think the co-chair has mentioned about the UDP part, and they said blah until it's up to UP user plan is up to 3GPP. Actually, it's the other way around. 3GPP itself is not going to standardize how it's going to be the map from the UDP port to the network slice side. 3GPP is not going to do that normative work. Thank you.
So the comment was not about that, right? Was it about whether
the comment is regarding the last bullet. The first line is to user plan is up to 3GPP. Actually, 3GPP is not going to standardize this one. There's no normative work for sure.
Okay, Tenji, I think what we're saying, is that VLAN, MPLS, and the segment parts are in 3GPP. If 3GPP is going to associate that UDP port, that part has to be done in 3GPP. If not, it will not be available to use. Yeah, I can take the change you want. We can see how. Maybe that is similar to the comment that I made. We can disassociate the two. Yeah.
Okay. Any other questions, comments?
Thank you.
So, but I think, John, one thing based on Satoru-san's feedback, right? I think maybe one more version, I think, with some clean before we even put it through a proper review process, right?
Okay.
So clean up, I think, whether with the language and then
yeah, I'd be happy to take comments that I can receive offline too.
Yeah.
So please contact me with any concerns that you have.
All right.
Thank you.
Again, I think we need some good reviews on that. We need more reviews on this document. We'll do that. Thank you, John. Which one is the next? Which one is the next topic? Oops. Or Marcos, probably. Next topic is mobile traffic steering. Mark Alavish.
All right. Yeah, mobile traffic steering. Is that on? Yeah. It sounds like a big term. We'll clarify in the next minute what's behind it. But it's a discussion that came up during the last well, month, years, whatever. And maybe it relates to the original roots of DMM. Let's see. We want to foster a discussion if it's worthwhile to do some work here, if there is interest from the working group, and in particular, if there is value in documenting and specifying something on that. Right, next one, please.
Okay.
Okay, so originally DMM exists since a long time, and it was meant to well, investigate the distribution of the mobility control plane, but also our data plane functions. Various concepts has been addressed, but all in all, if we look at an end-to-end system, as shown here, it comprises a mobility management system, which could be mobile IPv6 environment, anything. Also, what 3GPP specified in the past with packet core and today's 5G system. All of them utilize the concept of a mobility anchor. So here in the terms, it's a little bit mixed. Sorry, I was lazy and did not update the figure. But what you have is typically a control plane for mobility management. And then you have a mobility anchor, which can be a home agent in mobile IP, could be a local mobility anchor. In 3GPP terms, it could be a packet gateway or a user plane function. So from the anchor point towards the mobile device, that's the mobility management system. End-to-end view does not cover everything because there is a leftover segment from a mobility anchor up to an application service. In 3GPP terms, that's related to N6 reference point. DMM group in the past focused a lot on protocols between the mobility anchor and a mobile device, indicating segment routing with 6 kind of solutions, whatever. Another point is that today it's reality that even in 3GPP, user plane functions, mobility anchors become distributed. So they are not very much centralized, and a mobile device keeps its originally assigned mobility anchor forever. But there is more dynamic in such a system. And it's reality today that the mobility anchor of a mobile device gets relocated mid-session. So 3GPP has these modes in support, and in DMM, that was also discussed quite a long time ago. The objective during such a relocation of a mobility anchor mid-session is to keep sessions and services continued after mobility anchor relocation. Different concepts utilizing forwarding from one anchor to another one have been discussed. This is not about route optimization. So what we want to investigate again and look back is how we can steer traffic from an application service towards the current active mobility anchor of a mobile device. So this work is supposed to be independent of the mobility management system, whether this is mobile IP or 3GPP. But we look at, or could look at, solutions that work with any of these mobility management systems and well, try to work out how these systems, which is on the right-hand side, the transport network, on the left-hand side, the mobility management system, could interwork to make this possible. Next slide, please. You want me to push someone?
Yeah,
I'm
good.
Okay. So in brief, the target scenario is the following, that we may consider an IP address that has been assigned to a mobile device is continued, even if the mobility anchor is relocated. It's debatable if IP address continuity is valuable or not. There are other solutions to tackle that. But we always conclude that there may be still value in maintaining a US IP address, mobile nodes IP address. So if we show the mobility management system on the left-hand side below the mobility control plane as a very small area, because we don't plan to touch it. We don't want to modify it. But we focus on the right-hand side, which is the remaining segment in an end-to-end view between a mobility anchor and an application service or a data network. So whenever the mobility management system decides to relocate a mobility anchor for a mobile device, we want to ship its more anchored IP address to the new mobility anchor, which may, or for sure, make the mobile node IP address a non-routable IP address. So how can the mobility management system interact with the transport network control plane to steer the traffic in a route optimized way between the traffic source, which is a service in the data network, and the current mobility anchor of a mobile device? So that's all about it. Next one. Just 3 examples that this has actually been proposed in a couple of drafts in the past. And this is by far not a saturated list. We just picked 3. Well, actually, we picked 3 because these were the ones we discussed and I remember. For sure, there are plenty of others. So in 2012, we already brought a draft that tackles this problem by not focusing on the mobility management plane between a mobility anchor, which you see below here, that is actually relocated from the left to the right, but it focuses on the infrastructure between, plain old terms, correspondent node, which sends traffic to a mobile node, and the actual mobility anchor that becomes relocated here. So that approach was particularly leveraging identifier locator separation and makes use of IP address rewrite to bring the packet to the current anchor. Next one, please. There was another draft on N6 traffic steering. At that point in time, it utilizes already the reference point names from 3GPP, but I think in the meantime, the whole working group is aware of that. Nevertheless, it's the interface between a mobility anchor and the data network. And here, the draft already addresses interworking between the 2 control planes, which is a transport network controller on the right side and the 3GPP control plane on the left side. So there is interaction needed. And on the data plane itself, any kind of host routes or programmable transport network data plane can be leveraged here. So the draft is not specific on that, but it tries to tackle the problem that we want to raise here. Next one. Another one, just a couple of years back, also tries to generalize the problem of steering traffic between a traffic source and any kind of mobility anchor in the mobility management system, making use of a control plane. It's called mobility floating anchor. So all of these concepts still rely or assume there is a central node temporarily for the mobile node where all traffic has to traverse, which is known as mobility anchor. And here it makes use of transit routers that are configurable to steer the traffic from a source to the mobile node's mobility anchor, assuming that the anchor knows how to further forward packets to the mobile node's location. So these are drafts which try to address the problem in a generalized way. And we want to bring this up again, the awareness of the problem statement, and discuss with you if there is interest in particular value in doing some work here and documenting that. Next slide, which is the last one. So the discussion we want to bring up here is, first of all, if there is interest in such work. We should not ask every question alone, but first look at the whole thing and then see if there are comments, thoughts, and an interest and value in doing that. Interest is one thing, but there should also be value in documenting this. Maybe we find gaps that really require additional standardization of information models, semantics on a couple of related interfaces. So is there value and relevance of such work? Is there a customer of these documents in case we produce them? Technical scope of the work, again referring to this architecture here. On the left-hand side, we have any kind of mobility management system with a control plane and a data plane. Data plane leverages mobility anchor concept. Focus would be on the right-hand side for the remaining segments up to the application service and assuming any kind of transport network in between. So on the right-hand side, we have a transport control plane, very general concept, which interworks with a mobility control plane. So there is event information to be shipped. There is other semantics to be shipped to make this traffic steering approach happening. So this is something the working group could look at in a general way to see which messages, which attributes, values we need between these two control planes to make the system work. Another point that could be looked at is, and there are plenty, different control planes. So which control plane could be used to make this use case happen? I'm pretty sure that there are plenty. So the question is, should all of them be listed, analyzed, or documented? I don't think we can propose one particular one which we standardize. So that's a big point and question. So from a technical scope, what should be the focus here? Third one could be the interface semantics between the transport control plane and the data plane. And fourth, so which forwarding plane could be used here, compared, analyzed in terms of bringing packets from a source node to a mobility anchor. Last but not least, before we go to questions, is which could be the intended status and type of this document. Is it something like best current practices, informational drafts, whatever alternatives we have? And is this more an analysis, or well, we may conclude the document with gaps and then have standardization if there is anything to standardize in the next step? Okay, I think that opens the floor for any comments. 3.
Oh, no.
No?
Jeffrey.
Oh, okay, sorry.
Okay. Zhao Hui Zhang or Jeffrey Zhang from Juniper Networks. So my comment is in the context of 3GPP defined mobile networks. Previously, when this UPF is centrally located, then this problem does not exist. Of course, when we distribute it, then the problem happens. Service continuity includes both the IP address persistency and the traffic reordering, things like that. But even when you replace central UPF with distributed UPF, it's understandable that or reasonable to still have a central device, like a router in the data network. So as long as the distributed UPFs announces host routes and have that central data network router aggregate those host routes into the rest of the data network, and the address persistency will work. And that's actually the solution being proposed in 3GPP some time ago, but it didn't get taken up because they didn't think the problem was worth solving. And in here, the SRv6 map architecture also uses the host routes to handle that situation. But then when it comes to traffic reordering, when you send traffic, move from one anchor point to another anchor point, 3GPP has this way of this end marker to handle that. In IETF, we typically don't take care of those things. We think, yeah, we don't guarantee the ordering. And so in this case, if we want to handle that, then we can define some mechanism between the distributed UPF and the central router in the data network to do something similar. But if we do that, we could consider doing that in a generic way that applies to other scenario as well, not just for this. This is just some thoughts.
Yeah, thank you, Jeffrey, for the valuable comments. You address actually many aspects, and I fully agree that 3GPP's mechanism for end marker could also be applied here. They applied between base stations. Here it could be applied between mobility anchors. So, but that's a very particular problem that could also be addressed, right? But here we want to erase the problem, the very high level general problem. And I think what you refer to with the router in the data network, that really matches that picture here, because we draw a data plane node, which could be such router that you mentioned. I'm not clear, because I don't know, if 3GPP addresses and solves all aspects of how to enforce the host routes into that router. And so what we address here, matching 3GPP requirements, but any other mobility system requirements, to generalize a solution by looking at these 4 or less or more aspects, in particular the interworking between a mobility control plane and a transport control plane. But that's the discussion we want to have, if there is something that needs to be done.
Yeah, one quick point about the host routes advertised by the mobility anchor here. In 3GPP case, it's really not defined by the 3GPP, but as long as that UPF, distributed UPF, they announce their host routes on the N6 interface, then it should just be fine.
Okay, so they do this. Okay, I see.
So Marco, thank you for the presentation. So I think the key work you think is mostly on one, where the mobility control plane will expose certain state and also events over the subscriber device. Based on that, you want to do the provisioning on the 3, which is transport control plane and pushing new policies to the north N6 router or some router which is on the north of the mobility anchor. So what do you see is the work item in 4? Actually, 4 is not very clear to me. Is it not just applying a steering rule on the access router or aggregate router?
Well, I think there are different solutions that could be looked at to actually, assuming we have policies on the endpoints like the DPN here and the mobility anchor for uplink, downlink traffic steering. You could make use of encapsulation. We could make use of segment routing. So that's the point number 4. So there are different options what to make use of here.
But that does not require any standardization work, correct? Is it mostly about?
No, I don't think a single solution makes it all, right? So, but there are prominent options that could be used here, that could be looked at, analyzed in the view of pros and cons. So it's not clear if we need to draw a conclusion from that analysis or not, but 4 means there are alternatives, that's all. If we look at them and describe them, that's a discussion we need to have.
I understand, okay. Thank you.
David Lake. I'm interested in this problem. I think it's a really relevant problem, but I'm concerned that we're still looking at a GTP system here. And the truth is that for modern applications, the application layer deals with mobility across multiple endpoints. What we're looking at here, I think, is enhancements to the 3GPP network to maintain GTP and then distribute into the IP network. Shouldn't we be looking at a more holistic level of saying that what I want to do is access service, and actually to strip out a lot of the GTP and 3GPP items, which 90% of the time you don't need anymore. That allows you to move to an environment where we're talking about a mobile internet, as opposed to what we have today, which is private closed networks that then go through an aggregation point into the DN. And it's certainly something that's come up on some of the 6G IP links mailing lists, because we've been talking about the issues of connecting across multiple networks. For example, when I'm roaming, I have a different experience on a cellular network to that on a wireline network. Is there any way that we could look more at what the application wants to do rather than what the network is doing? And could we start removing some of the layer 2 that we've inherited from GPRS that exists in 3GPP and actually move to a true IETF network, which is IP end-to-end across this?
I think that this is also, well, again, multiple valuable comments, not only a single one. But so first of all, if we think about and see value in documenting something here, I don't see in this document the term GDP, right? Because we actually want to abstract from that. So you referred to the mobility management system.
But N3 is GTP.
N3 is GTP, but here we don't see N3 anymore. Right,
Right, but my end device has an IP address, and I access video or WhatsApp,
Yes.
and I don't care whether I'm connected to Wi-Fi here or IP service delivered by a local PTT, a bit pipe carrier. I just connect.
Yes.
And actually HTTP and things like WhatsApp is doing a better job than some of the carrier-orientated services in providing my service. So a lot of this is actually becoming hidden from the end user. And what we need to be doing is getting to a point where the application is able to tell the network what it wants at any one time. And I just connect. You know, if I'm on an IP call and I move between wireless and local cellular or other cellular, it just works. I'm not actually using any of these pieces in here.
No.
So can we start stripping some of the 3GPP stuff out and start making it into an IP end-to-end network?
Again, we plan to strip the 3GPP work out of that, because we assume between mobility anchor and mobile node, it's a mobility management system knowing how to deliver packets, whether this is GTP or anything else, or if this is a mobile IP home agent and using IP encapsulation, right? So you address another aspect, which is that higher layers may be able to tackle that problem. And that's why we said, let's think if there is still value in IP address continuity, because we have protocols that don't, or applications with the transport protocol that don't depend on IP address continuity, right?
Absolutely.
So this problem originally addresses the point of IP address continuity. So we want to transfer an IP address of a mobile node from one mobility anchor to another one, which makes it not routable in a default routing manner anymore. So we need to have host routes or whatever kind of scheme to deliver the packet in a route optimized way. If we don't depend on IP address continuity, there are more solutions tackling that with what you just referred to. So that's also a question if we want to look at these schemes, which is actually a little bit off topic from what we want to address here. But if there is value, we could think about doing that.
I agree there is, and there's been a lot of talk, especially on the 6G IP mailing list, which hasn't come to a meeting yet, about what do we actually need. If I'm thinking about a network as being, you know, it could be a cellular provider provided by a local company, it could be a wireline, it could be Wi-Fi, it could be whatever. What matters from the user perspective is the application. I don't care whose network I'm using.
No.
And in fact, a lot of the services, such as the voice services and the text services, are being walled gardened into the operator and forcing users to go beyond that. So I think this is very interesting, but I'd like to take it almost wider and say, do we actually need anchor points in here?
Yeah,
so I think it's a really interesting point. Thank you.
Please take offline.
Yes,
Yeah.
I think.
Thank you.
I have a couple of comments. I would like to continue that offline.
Yes, actually.
Very quick.
NG. Yeah, it will be quick here. I can answer your question. 3GPP has already defined the non-3GPP access when you have a both cellular and also like non-3GPP like wireline or wireless. So that one is in the spec already. So it's at least my understanding is it's not going to add additional complex to this is interesting work. I want to comment on the two parts. I would suggest if you have read or not read the 23.501 from 3GPP, it has give two things. One is a 3 SSC mode service and what the continuity SSC. I forget what the second is. So it talk about like a break and make break, all kind of things, and it's going to address something as you have tried to describe here. The other part is in the 3GPP spec, it has given three different ways to allocate the IP addresses, like either the UPF or as you said, the mobile anchor bound, or SMS bound, or even the DMM bound. So for all the three different things, so you can combine them together. Something has been handled already in your in the question you raised in your draft, but something from my
please make your comments short.
Yeah. So basically, I just gave you the comments. You can look at that. It's interesting work. Thank you.
Thank you very much. So in total, I conclude there is interest. What is in particular to be looked at is something for further discussion. In depth, I agree to all comments that for sure we need to have at least the understanding of the mobility management system and see what 3GPP or in IETF has been done to support this. But that's the detailed work. If we agree to work on it, we can look at it. Okay. Thanks a lot.
Thank you, Marco. I think let's continue these discussions in the mailer. I think there are a lot of good feedback. Please, post those comments in the mailer and let's see what comes out. Yeah. Thank you.
TNG.
Next one is TNG. Which
Yep.
what is it? Something of the time.
You can find the Miteko. Please open the Miteko.
Okay, but here I should have.
This one. This one.
Oh, sorry. Yeah. Sorry.
So it's the,
One second.
it's a PPT. So
Yeah, I'm sharing one second.
Chrome tab.
Okay. Good morning. TNG from China Mobile here. This is a draft with many co-authors. Can you go to the next one? I thought I gave the PowerPoint. No? Oh, okay. But anyway, here, for the first couple of slides, it's just some basic ideas, what has been covered since this is the version jump from 02 to 04. We presented the 02 version in London, and then this is the 04. For the basic idea here is from the UPF, distributed UPF, and then that one is going to be close to the Genobi. And then there are some good things about the if you put the DUPF close to Genobi and for some MEC, the mobile edge computing, private network, and the local internet peering, all kind of good things. But when we talk about the B5G, beyond 5G or 6G, so the things like what if there are more demanding use cases or scenarios that may benefit from the integration of the access network or access node with the UPF part. So in the draft, we call it the ANOOP. Here, there are some things about some backgrounds. So yeah, can you go to the next one? So the basic thing is just like, okay, can we, well, for the beyond 5G or 6G, can we integrate the access node with the UPF part? So this is just some picture about, okay, from the UPF part to the integrated. So yeah, can you go to the next one? So just the background so far. Can you go to the next one? Yeah, here is look at still we want to emphasize the work or the work here will be done in 3GPP. But the thing here, 3GPP so far is in release 18 in the SA2 architecture working group, release 18, and then in the coming June they're going to starting work on release 19, and then after that for another 18 months and then go to 6G. So basically, the work in 3GPP on this type of advanced research or investigation is kind of 2 years behind. That's why we want to raise this interesting topic and to socialize the interest and the support from the IETF. Yes, and then compare with the 02 version here, we are getting more interest and support from operators and vendors. This is some old discussion in the 115 London. So yeah, not significant for today. So can we go to the next one? Yeah, here we want to discuss today just like some ID change and some update to be added since there are some new changes happened last month in 3GPP part. So this time we haven't found the time to add into the 04 version, but we do plan to introduce to the next version of the draft. Can you go to next? Next slide, please. Oh yeah, here it's just some basic idea we have added to the draft. The first one is more authors, that is great, and the more operators, vendors support. And for the other three part is the change we add in is more on mobility features. One is like a mobility handover, how it's going to be handled, and then how the ANOOP is going to benefit this one. And the paging is like when the UE in different mode, or even in discontinuous reception mode, or mobile MIC, or like a mobile initiated connected mode, those type of things, how the ANOOP is going to benefit. And the last one is just like implementation specific pros and cons for microservice architecture. These are three technical changes and one the author changes. So that is something we have added to the version 4, but starting here is something we are planning to add since we really truly believe the use case on satellite part is going to benefit from the ANOOP architecture. Here is just some basic diagrams about, okay, for the 3GPP satellite use cases, and then you're going to have satellite network either on the access, basically from the UE, and then go through the feeder link, GW feeder link, and then go to mobile access. The GNOB is onboard satellite. The lower part is the GNOB still GNOB itself is still on the ground, but the UPF is onboard satellite. These two diagrams I borrowed from another draft. I'm one of the co-authors. Okay, can you continue the next one? You go up a little bit. Here, this is a busy slide, a lot of words. That no need to worry about too much about the details. It's regarding the 3GPP use cases or 3GPP projects that have been going on. One is in release 18 in the SA2 architecture. Sorry, SA2 working group is ongoing. The other one is I made a mistake actually. The second one is SA1 actually, satellite access part, that is in release 19. So I'm going to change. Correct it. So for this access case, you can consider, okay, well, the UE and the GW, well, on the ground, well, the GNOB and GNOB is onboard satellite, and the UPF. So basically, radio base station is onboard satellite, and the UPF can be cannot be on satellite. So if they are not. Someone is on the satellite, someone is not. So it's going to introduce a lot of complexity regarding the signaling, regarding we call the routing, but there's a lot of control plane synchronization between the RAN and between the radio, the GNOB and the UPF. So that is going to introduce the one dimension of complexity to the mobile service. So for this one is regarding just for the sake of complexity, since the GNOB is on the ground while the satellite is on board, while the UPF is on board satellite. So there are also here the talk about all kind of the benefit. I'll talk about the challenges in different cases, like in a LEO case, like MEO and the involvement with the multi-ISL inter-satellite links. So I include here for the completeness of the work. Yeah, can you go? So this, can you go to the next? Yeah. So, so when we talk about the use cases and look at the ANU work we have drafted and composed in our internet draft, and then you can see, okay, well, when lot of like the moving targets are being introduced, like the satellite part, and then we start to see a lot of challenges. And then people may ask, okay, so is that like a 3GPP work and they're too much advanced or something? But actually it's not. Here in this slide, we are showing one, we call it the feature. It's called the local IP access that has been standardized in 3GPP tech spec 23.401. So this is in the LTE spec. It's been there already. And then 23.501 is for 5G, by the way. So in the picture, if you look at in the middle toward the left, it's called HENB. You can consider it's like a radio part, and then our GNOB as the comparable in the 5G. So L gateway, the local gateway here, and also toward the left side, and then you can see the HENB and the LGW are co-located. Actually, here I want to emphasize, it's not just the co-located. There is no interface defined at all between HENB, home E gateway, and home E node B, and the local gateway. So this bodes well for the work we are proposing here. So like, okay, so 3GPP has already discussed it, and then it has already provided features, and it's going to simplify the signaling, simplify the control plane for all kind of like the IP offloading. So for all the work or benefit are going to benefit from the IETF perspective, we have described in the draft already. So this one is really bode well for the work we are proposing. Okay, on the last line showing what is the spec, they're talking about the LIPA. Okay, so this is the last slide. So appreciate all the comments, and then actually from the version 00 and 04, we have received lots of good comments and more interest and support from operators and vendors. And we'll continue to do the work. And also, I hope we can socialize with IETF people. And also, if you have your colleagues, I'm sure, since the 5G network is more toward integration with the IP part. And then also the thing is, as I mentioned at the very beginning, so far for 5G is I think about 2 years away from the 6G planning. So we want to work ahead of it. And although we know at the end architecture will be investigated in the 3GPP, but here there are a lot of things can benefit IETF and IETF, and also can get something from here. Sure, thank you.
All right, thank you. So one quick question: do you see any relation to the previous presentation from Marco? Any relation? The routing problems are still the same?
Marco, the routing, I forget which.
Okay, we can take it off.
I forget the routing itself is going to benefit for sure, since if you make the GNOB and the UPF integrated, and then there's no more interface on the for 5G the N3 interface. So that is like a GTP, all kind of things. So
thank you so much. I think let's have more discussions.
Okay, sure.
Yeah.
Okay, sure, no problem. Thank you.
Next is okay. All right. So this is, I want to get some feedback on this document. It's not necessarily a DMM document, but I thought I'll get some working group feedback on this. Sorry. So this is the essentially, if you some background. So FCC, the CSRIC 8 working group is looking at solutions for supporting E911 over Wi-Fi. I think so. This is the charter for that group. This is working group 4. Mainly the topic is 911 service over Wi-Fi. The idea is that this working group is going to provide certain recommendations to the FCC Council so that they can do rule making for, I think the larger goal is how can we, today, how, if you look at the 911 calling, it's very well supported in cellular access, right? Now, in many environments, a user may be in a basement or in those environments, there's no access to public network, public cellular network. In such scenarios, how can the user make use of the Wi-Fi network that is available and quickly make an emergency 911 call? So that is the larger goal. In other words, how can we provide a greater access to 911 services from any of the available networks or Wi-Fi network in question? So for that, so the 3 scenarios that are in question, if you look at if you characterize the user environments, one is a public cellular network. My device has a SIM card, a cellular 5G or 4G cellular module, and it is in the proximity of a public cellular network. Now, if you look at the 3GPP defined procedures, the device can latch on even with an expired SIM credentials or with no SIM card. It can activate the emergency procedures and make a 911 call. Now the question is, let's take the case where the device, there's no public cellular network, or the device is Wi-Fi only capable device. There's no cellular module. In such scenarios, now if there is a Wi-Fi network that is available, can the device make use of that access network and make the emergency 911 call? I think that is the scenario 2, the middle scenario is what the focus of that working group. Like how can we provide, can we come out with more mechanisms where the endpoint can make use of the available network and make the call. Now, a third scenario is again, there's no public cellular network, but it's the user device has some access to some Wi-Fi network. Maybe it's not a managed Wi-Fi network, but it has connectivity. Even then, can it make the 911 call? I think we by default think that, yeah, if there's a connectivity, I can make a 911 call. But if you look at it carefully, the dialer today that's in an endpoint, the dialer is somewhat, the default dialer is bound to a cellular module. Meaning I cannot press 911 and expect the call to terminate an IMS network. So the question is, how can, in both scenario 2 and 3, what configuration we can provide to the endpoint so that it can make a 911 call? So these are the 2 scenarios, but in question, I think the solution, now if you look at the scenario description, the use case is I have a device, it is Wi-Fi capable. Maybe it has SIM, maybe it doesn't have SIM. But there's no assumption that the device is pre-configured with a default emergency pass point profile. So now I'm touching the solution elements. I think what the proposal is about, can we standardize or at least make sure that there's an emergency pass point profile that is configured in every endpoint. I think that's the rule making that we are asking FCC to say that there's a pass point profile. Pass point is well supported across all device ecosystem. Can we define a special pass point profile that's intended for emergency access? If that profile comes maybe as part of the manufacturing process, right? Apple, Samsung's by default install that profile, or as part of the carrier bundle, they download it, or maybe enterprise networks can push such a profile, or a user may download such an emergency pass point profile. Now, I think the goal being, we don't require new changes, new mechanisms on the endpoint, because pass point is well supported. Now, if there is a pass point profile on the endpoint, now if the Wi-Fi networks are mandated to support such pass point profiles, can it make the call? Now, the assumption is again, there's no cellular network available, there's no HPLMN, VPLMN, there's no RAN available or the IMS core, but what is available is an access network. It supports emergency, access. Now, in that, my device will latch on, get the necessary, discover that network. By the way, I don't have access to this access network, but because it's an emergency call, can I latch on to the network that's available with some hotspot, public hotspot, and make that call? So the outcome that we are expecting is like, any device if it's in the vicinity of a hotspot will be able to obtain a configuration, latch on, and make the 911 call. Now, the key solution elements, if you look at it, how does the device identify the network? What is the new pass point profile that FCC can standardize, or the parameters rather, and then what regulatory framework that is required? I think the question is, see, there's also about liability. 911, if you look at it, 802.11u, it had some semantics for even 10-15 years back, but it had no traction. The algorithm, the method that was specified, nobody implemented it, it's not there, and it's also no network support that, because it's about a liability. Now the question is, if an access network supports emergency pass point profiles, can FCC come in and say, you are not taking the liability. If there's a call failure, we will step in and we'll protect you. So as part of that, I think the overall discussion is also about what tools, or what is a framework that we can define so that the access networks are not liable for any issues around call failures. And the third aspect is how the location is fundamental. If I'm making a 911 call, the emergency dispatch services should know where exactly I am. What I'm claiming for, the location that I'm claiming should be indeed the location that I'm making the call from. So mechanisms have to be foolproof. Somehow the 911 system, the operator should be able to know that, yeah, it is not a fake call. So, and the final, I think these are the two things, signaling and the detecting of rogue. These are the technical elements in the solution. Now, I think the mechanism, what we are proposing is based on the open roaming framework. WBA has defined 2 small slides. I'll ask for questions. So this is the overall system architecture. What we are proposing is based on the WBA's open roaming. WBA is, what WBA has defined is an alternative to carriers GSMA's GSMA's roaming. GSMA's is one-to-one. Verizon talk to AT&T, there's a one-to-one relationships. Based on that, today I can roam into any other network. But what WBA is doing is exactly for Wi-Fi. Essentially, one-to-many, right? Essentially, they have defined a cloud, federation. There's a set of access networks. There's a set of identity providers. CAN and endpoint. The idea is that the federation is making sure that I, with any access credentials, can, as long as if I'm in the presence of an access network that supports that RCOI, roaming consortium ID, right? I should be able to latch on, and I should be able to use my IDP credentials and make the call. So that's a framework that WBA has defined. Now here, what we are providing is essentially extending that. Pass point profiles are standard. All we are standardizing is a new emergency roaming consortium ID. That device will have pass point profile. The access network will support. It will latch on, and we have solved the location problem. So these are the overall solution elements. I may not have enough time to cover this discussion here, but these are the different solution elements in here, and some call flows, right? So some threat analysis. This is what I think the feedback that I'm looking for is, should IETF do something in here? Again, I'm talking to Eric as well. What's the right group for this? But generally, art is what we are looking at. But generally, I'd love to get some feedback from this group. Questions?
Salaway Jalil, just a clarification question. So you can call 911 from Wi-Fi today, but the location normally is set in your profile, so it doesn't follow. But you can make calls today. Are you saying you can't make 911 calls from Wi-Fi?
So the question is, see, I think if you're talking about a carrier Wi-Fi calling, I'm again going to some provider. Right now, the question is, when you say today you can make a 911 call, where is the IMS network? Where is the call terminating?
No, I understand the details. Like today, I'm on Wi-Fi calling. If I call 911 now, they'll come to my house in the US. So I can make a call 911.
But you have a cellular subscription, right? Okay. You're making a Wi-Fi calling, which is again going through EPDG and going to your operator. Yeah. So your call is again terminating on your IMS network that your device has.
Okay.
Now here the assumption is the device, let's take the case, it has no cellular SIM card at all.
Okay, so this is just a phone that has no service.
And yeah, no SIM card, that is one case. And also, there's no public network available in that environment.
Gotcha. Okay, thanks.
Yes.
I think it's related to the other problem, that what we've done is tied ourselves into a 3GPP centric solution. And actually what we're looking at in terms of an endpoint is a SIP endpoint. So my IMS client is SIP. It's just that I have the authentication and the EPDG nonsense behind it that ties me in. So for example, I'm here at the moment, I'm on an IETF network. At home, I'm on an EPDG from Vodafone. Vodafone don't allow me to use Wi-Fi calling. I have to go through the roaming. So I'm on circuit switched effectively. If I go to the US, I have no 2G, no 3G. I can't actually make a phone call at all.
Right.
But I can make SIP calls and I can make IP calls. So I think the problem here.
No, I do want to clarify one thing, right? You're making an assumption that your device is able to connect to the network that's available. I think so. There is the connectivity problem as well. How do I get connectivity? I think that is.
So I think there's two problems. There's a connectivity problem, which here is Wi-Fi.
Yeah.
There's also then a services problem, which is the fact that I have EPTG, I have all the economics associated with roaming. You know, carriers want me to roam. They don't want me to use Wi-Fi calling.
Yeah.
So many countries, many operators are now blocking Wi-Fi calling if you're out of country because they want to make money from the roaming solution. That then pushes you back to using circuit switch where there is circuit switched available. If I get into a situation where circuit switched is switched off, 2G, 3G, I could do an emergency attach without a SIM card, and I could do a 2G, 3G call. There ought to be a similar concept within 5G, 4G, 5G to enable me to do that, simply to get an IP session that has known credentials that connects me. Now, in terms of location, we have a perfect location system. It's IP. By knowing the IP endpoint address, knowing where I've attached, I know exactly where I'm located.
We should
within a public network.
Right.
Now, if you get to a private network, such as a cellular operator, they hide that, and I understand that. So I think there's two problems. There's the architecture of 3GPP, which is holding us back, and then there's the fact of the connection of any sort. But yes, it's an interesting problem because I think it actually is a wider, a subset of the overall problem we've got in terms of 3GPP.
No, great comments. I think one thing I want to clarify is the IP address is not a representative of the accuracy that you need. You need much more granular location. I think that's one.
So could we take GPS into consideration and have some system that drops GPS into a SIP header?
I think that's absolutely. I think quick. I think I think you want to say how much time we have.
2 minutes.
2 minutes. Okay, 2 minutes to wrap up all the discussion. Yeah.
Okay, Jeffrey from Juniper. So technology-wise, I see two problems to solve. One is that being able to latch onto the network without being a subscriber. Second one is location. Inside a Wi-Fi network, where exactly are you? Those two problems, neither of them seem to be relevant to this group or even to IETF. That's how I see it.
Thank you, Jeffrey. Eric.
Eric Klein, just as an individual, I put it in the chat, but there is RFC 6225 that the GeoPriv working group so I put together. It's a DHCP option that things can tell you like roughly where you are, depending on your Wi-Fi location. Obviously, you could be quite far away from that, but you could still be within a city block or something. In theory.
Right. I think the DHCP options are again two things. You can signal the endpoint, Eric. But the question is now when those elements are signaled back in the SIP and you headed to the SIP proxy, you have to trust the network endpoint. Now, what if it's a compromised client? Now the signal location I may be here. I can signal DHCP may be sending the right options, but I may be sending some incorrect. I may claim that I'm in Tokyo right now. I can make the 911 call. So the question is, the solution is also here. What we are looking at is, can we cross-correlate what the access network is saying in what the endpoint is saying, what also an access point, a trusted access point can signal. That way you can correlate the two and we can be certain about the location. That's also another answer.
Yeah, it sounds like if this belongs anywhere, it belongs somewhere in art area.
Okay, all right, thanks.
Quick question. See, this should be, is it your idea to standardize the secure location in IETF or?
That's a good question. I think maybe its option is I think the question is how we deliver it to the endpoint.
Right.
If you are delivering it over 802.11, it goes to IEEE. But if I'm delivering that as part of DHCP option, it belongs here in IETF. So I think depends on the protocol that we are using for delivering the SLT tag to the endpoint.
Okay, so from IETF perspective, since there are already something DHCP, so but you mentioned that access point is giving a secure location, and I'm just trying to understand that what would be the
that's a great
scope here.
question, actually.
Yeah.
So what Eric is referring to is, DHCP, the specification where a router can signal
Right.
a DHCP, or DHCP server can provide but those location coordinates may not mean anything. With SLT, it's a dynamically generated tag. Now SLT is indexed back to the real location. That way, when the E911 system can cross correlate, I cannot make up an SLT tag because it will index to a real location. So
Right.
there's a relation between the SLT and the physical location. So the current options are only about signaling a real location that may not solve the spoofing problem. We can take it offline.
Okay,
actually.
thanks.
So, sorry about that. Yeah. Okay, I'm done with this.
15 minutes to end this meeting, right?
No.
11:30?
11:30. Yeah. Yeah. I'm done. What is the next topic? You want to run it on here?
Can you share my screen?
Can you share? We have to go. You want to share only this? Okay. Oh, no, it's okay. It's okay.
Can you stop the sharing?
Oh.
Stop the sharing.
Yeah. Sorry about that. Yeah. So this my architecture on the using SR for DMM. Yeah.
Hello, everyone. This is Satoru from SoftBank. I present map architecture using segment routing for DMM on behalf of our co-authors here. Please, next slide. Okay, this is the not the content in the draft itself so far, but we have very good discussion with Jeffrey to consider the data plane option in the segment routing. So as you already know that SR has the two data plane option, IPv6 and MPLS. Currently we focus on the SRv6 case only because the some level of the scalability much suitable for a very highly distributed environment. So before to explain the data plane option discussion, I need to explain how the SRv6 map works for a highly distributed radio network to be covered. So you can see the left-hand side, the cell site connected to the map P. Maybe that map P could be a cell site router. Each cell site has a IP address. In this case, one antenna has a 2001 dB8 beef added to cafe inside of the same interwork segment. 201 dB8/64. So in that segment, be advertised through the routing protocol. In case this be BGP, so the left-hand side PE advertise the route with the prefix for a segment. In this case, 201 dB8/64 with the service set S:16. So then the left-hand side PE receive that route to keep inside of the their lib. So please go to next slide. So now a cell phone connected to the antenna. One is 1-to-1-to-1-to-1 connected to the antenna beef. Other is 2.2.2.2 connected to the cafe. So then the map C will be appear to advertise those UE address route. So please go to next slide. No. Go back. Yeah, a little bit. Oh.
It's too fast.
No. Please go back.
It's good.
No.
Sure.
The number 5, I think you want slide 5.
I don't see slide numbers here. Sorry.
No. Go back.
Go back.
Go back. Go back.
This is 5.
Please.
Right?
No. Go back. Oh. Oh, that's one. So after the UE attached, the MAPC advertised the UE route in the type 1 session transformed route. The one route is the 1.1.1 and attached to the beef, 2.2.2 attached to the cafe. So then that session transformed route be received at the right-hand PE. Then the PE by themselves resolve the antenna address using the advertised segment discovery route from the left-hand side PE. So they found the prefix to resolve the ST1 route GNOB address, and then adopt the service seed to forward the packet in the field. That's how map architecture works to cover the highly distributed access network. So we can consider the much granular case for advertising discovery route. What if the left-hand side PE advertise the two antenna address in the independent segment discovery route? So the one is for beef with the service seed beef, and other is discovery route for a cafe with the service seed the cafe. In that situation, left-hand side PE can also resolve the their right station, base station address in the ST route. So the right-hand side PE found the service seed beef to forward the packet, and also the for the 1.1.1. So for 2.2.2, the right-hand side PE find the cafe to forward the packet toward the 2.2.2. That's most granular case. It's kind of the exact match case. So this is the variation of how much the granularly be supported. Longest match for scalability, exact match for much granular precise operation. It's a pros-con trade-off. Scalability, precise. That's the discussion consideration to cover the other data plane option. The other SR data plane option on the other side is the exact match paradigm. So then if we can manipulate the length of the discovery route, it could be supported. So that's what we discussed with Jeffrey. Thank you very much for his effort. So by the way, I hosted the hackathon project yesterday. We have many implementer for BGP MapSAFI implementation, ARCAS, and Cisco, ExaBGP, FRR, Furukawa, GoBGP, and also the OpenBMP. All of them now has their own code for BGP MapSAFI. Thank you very much for that hackathon member. We did interop as well in this matrix. It's you can expect that the hackathon is a very busy project and table, but we had a lot of fun. You can find that slide in this URL. The other demo be hosted on the yesterday's reception. The map working code and demo is now available and up and running. So if you are interested in, please call me. So our next step, I think it'd be good or not. So does the data plane option consideration need to be included in the architecture or not? Because the map architecture covers the SR data plane option. So otherwise, be much illustration for a better understanding if required. Working group adoption, I think I need still additional consideration to ask the adoption. Thank you very much.
Okay.
Question?
Thank you, Satoru-san. Any questions, comments?
Very quick. Here in your presentation, I cannot differentiate. Are you going to use the N6, N3, or N9? Well, look at the hexagon. It seems you are targeting for the N3. So, yeah, can you clarify? Thank you.
Thank you.
Okay. Any other questions?
Jeffrey from Juniper. So this map architecture, I think the key is that the GDP in-cap, decap happens locally as close to the GNOB as possible in the 3GPP case. And then after that, the packet is either locally routed to a edge computing server, or can be VPN routed to the central data network sites. So that that's the key of this architecture. And what happens in the VPN routing between the PE or gateway close to the GNOB and the rest of data network, that is indeed agnostic to whether it's SRv6 or MPLS. But the issue that was presented here about the host routes versus prefix routes, that is only applicable when you do the tunnel stitching on that map PE or map gateway next to the GNOB. Because if you don't do the tunnel stitching and you simply have the downlink routes sent to the closest PE and then do another lookup there, in that case, then you don't need that prefix routes or host routes even for the MPLS data plane. So just some clarification there. And as for working group adoption, I think we were talking about make this truly SR agnostic. In fact, it's not this architecture. I call it SR agnostic. It means that even if you don't do SR at all, if it's just MPLS, plain old MPLS, it still works. So this is that's a key point I want to emphasize. I think we should make this truly generic and before the adoption. I do support that adoption, and once we get to that stage. Yeah. Thanks.
Okay. Thank you.
Thank you very much. I think this SR is the kind of the found architecture, not just limited to the SR network, because SR is kind of the phrase. So non-SR node can understand if they upgrade it. Of course, to support the map, they need to be updated. Otherwise, so then,
yeah, they need to be upgraded. They need to support these procedures in this, but still, it can be SR agnostic at all. It does not really require any SR technology. It's plain old MPLS works. That's what I wanted to mention.
Let's take it down.
Yeah.
Okay. Next, anything? Okay, you're done, Sato-san? Okay.
Thank you.
Thank you. Next one is mobility capability. We have two more presentations, I believe. Mobility capability negotiations, ZV. Can I go?
Yeah.
Back. Sorry. Okay. I could not run the slides. Sorry about that.
You will?
Sorry. I could not run the slides. I thought in case I have to go in there.
So you need to leave to another room. Next presenter is Mia. Here you go.
Okay. Hello, my name is Mia Kono. I'd like to discuss about the architecture for the SRv6 mobile user plane. So today I'd like to quickly go through the objective which has been reviewed and architecture overview, problem definition, and 5G use cases, and conclusion next step. So at first, the objective is maybe we thought too big, and but we have reviewed, and this time we'd like to focus on the very essential essential things of the SRv6 mobile user plane architecture. So the document, the draft discusses the solution approach and its architectural benefits of translating mobile session information into routing information, applying segment routing capabilities, and operating in a routing paradigm. This draft is also meant to be an informational document to describe the motivations to the DMM SRv6 works. So this is the architectural overview. So conventional 3GPP mobile architecture requires a lot of GTP sessions, which are terminated by UPF. And for distributed edge use cases, the intermediate UPF would branch the traffic, or UE is select UE to select the distributed UPF. SRv6 map converts session information to routing information and apply SR capabilities and operates in a routing paradigm. So here is a problem definition. So with conventional mobile architecture, it's non-optimal for any-to-any communications, non-optimal for edge distributed computing, and non-optimal for fixed and mobile convergence. As you see the slide, for converging the access method, fixed and mobility, they need EPDG, and non-3GPP access should also be terminated in UPF, which doesn't scale, and it requires cost. And also there's no control of the underlay path since GTP is overlay tunnel. And here is the 5G use cases which are discussing, which are discussed under 5G. So one is network slicing, but so 3GPP network slicing basically defines about how to signal to select the different slices. And as it is, it cannot be mapped to a transport slice. And with map, which converts session information to routing information and operating in a routing paradigm. So necessary session information like SSD and SSAI in the 3GPP signaling can be mapped to a routing information with color, for example. And SR capabilities for SLA-aware logical separation can be naturally applied to such kind of scenario. Next slide, please. And for edge computing, it requires a lot of complexity in terms of the signaling. So 3GPP defines three models, so distributed UPF or UPF to branch steer the traffic, or UE to select the suitable UPF. But it requires a lot of signaling to to establish tunnel session, to find the edge server, to find the right edge server, and also to select UPF is also done by session signaling. And routing paradigm naturally enables ubiquitous computing. Next slide, please. And URLC as well. So GTPU tunnel has no underlay control. So in order to ensure ultra reliability, they are considering to have redundant path. But still, there is no way to ensure that such redundant path don't share risks. So it could be share the same physical pipe, but using the routing paradigm in SR, there is TI-LFA, which could protect the session within 15 millisecond. And also it can be, TI-LFA can be color aware, slice aware. Also, we can have disjoint TE path or disjoint flex algo plane. So it is more easy and straightforward to ensure URLC service as well. Next slide, please. So despite the twist and turn so far, the essence of MUP proposal is to convert session information into routing information, and this document has simply focused on that. And this draft is meant to be informational document to describe the motivations to the DMM SRv6 MUP works. So we'd like to ask working group adoption. Thank you very much.
Thank you. How many people read this document? Okay. So thank you very much. I think we need more reader to for this draft for the adoption. So please read this draft and then discuss online and offline. Thank you.
Thank you very much.
So next presenter.
Hello, Sadolo-san. I'm
Yes.
remotely private to the draft.
Yes. You present remotely?
Yeah.
Okay. I think you can share your screen.
Okay. Okay. Actually, this draft was discussed twice or three times in the past. But with the development and the 5G and the related mobility function extensions, and also the focus of the work in the DMM, we think it can be a part of the 5G mobility management information. And in order to clearly analyze the possible cases and actual requirements, the mobility management protocols are classified as the figure shows. From the large aspect, they can be classified into network-based and host-based. In each category, there are two classes. For example, in the network-based class, there are PMIPv6 and its extensions. And the other type is other kinds of network-based protocols, similar as in the host-based classes. Then there are many possible cases based on different capabilities and preference between host and the network. And the question is, a protocol should be selected when the host accesses the network initially and during the handover. We simply list some principles for the protocol selection. For example, in order to improve the efficiency and reduce the load on the terminal, the network-based protocol should have higher priority. And besides, a scheme is needed in order to negotiate the capability and preference between the terminal and the network. So we use the mobility pattern here because due to the uneven space time distribution of mobile data traffic and frequent users switching in the 5G system, the 5G core network function still has a problem and unbalanced load, especially when the end user accesses the 5G communication system or the end user moves between 5G base stations or different access networks. The access network needs to allocate the access and handover requests of the end user to the AMF to carry and process them. To characterize and optimize the mobility pattern of end user, the subscription of the user statistics of the user mobility, network local policy, and user assisted information, or any combination of them should be analyzed during according to the 5G specification. And the AMF determines and updates mobility pattern of the end user based on the subscription of the user, statistics of the end user mobility, and network local policy, and any others. The statistics of the end user mobility can be historical or expected end user moving trajectory. And if the NWDAF is deployed, the statistics of the end user mobility can also be analyzed and provided by the NWDAF. So as illustrated above, mobility capability can be a parameter as the end user communication analysis function to realize a customized mobility management. And I think this is the main change of the draft from the past to this version. And then we think the mobility capability should be considered as a kind of parameter during the end user mobility information collection. And furthermore, the most suitable and preferred mobility management protocol can be selected for the specific end user. I know many of the guys here are experts of 5G, and we hope we can further design the details of this function. So that's all, and thank you very much. And we also want to know, is it possible for a working group adoption of this draft? Thank you.
Thank you very much. Any question, comment, feedback? Carlos?
Yes, can you hear me well?
Yep, we can hear you.
Carlos from UC3. Just a clarifying question. I haven't read the document, so apologies for that. But based on your presentation, I missed a bit what is the IETF scope for this work. I see a lot 3GPP, but I'm not sure what is the impact on IETF specs from what you have presented. Thanks.
Man, can you answer? Can you speak?
Sorry, I didn't catch the main point of Carlos.
Maybe I can just rephrase. So my question is that what is the scope of the relevance of what you have presented for IETF work? So I don't see the link to IETF protocols from what you have presented. I see something that is 100% 3GPP specific from what I understood, and I'm sure I'm missing many things. So that's why I'm asking, what is the relation to IETF protocols?
Actually, I didn't. We didn't aim to change IP protocols, but we want, because we have standardized many different mobility management protocols. But I think in a 5G environment, is it possible to make good use of these protocols? And so we think as a mobility pattern parameter, the terminal and the network can communicate with some manners to negotiate the protocol. So and I know there are many details should be designed later.
Tianji?
Kenji, China Mobile here. I think this is interesting work, but I really want to you, the authors, to clarify about how you're going to use the stats from NWDF. That is more on the 5G system itself. So if you can find, I'm also trying to think aloud here, see how can the work to give a way to map those information to the IETF domain. That is very interesting for the mobile management. So I do think this is a good work for the working group DMM, as long as that one can be digged out. Thank you.
Okay, thank you.
Thank you. So next presenter is Carlos.
Okay, can I share my slides?
Yes, I can see.
Okay.
Can you stop sharing, ma'am?
Okay. Can you see my screen now? Not yet?
Please try again. Sorry.
Okay, let me see. Let me see. No?
Yes.
Okay. So very quickly, because I guess I'm the last one before you, or preventing you to go to your break. So this work that relates a bit to DMM, but is mainly related to raw, reliable and available wireless. And it's basically about how to enable mobility in a reliable and available wireless environment. So just a bit of the aim and scope. There are several use cases where we need reliability and availability for wireless. So this is the main aim for the raw working group. And in where we may have that those devices that demand reliability and availability may also be mobile. And just for you guys, maybe some of you are not familiar with what the raw working group is doing. So far, that working group has been focusing on the general framework and architecture and use cases, and the specific mobility scenario or mobility use case or feature has not been considered yet. So the goals of this document is basically to discuss what will be required to be done to enable mobility in a raw scenario from the control plane point of view. And then in our case, we define a solution that is based on mobile IPv6. So basically provides or extends mobile IPv6 to implement these control plane extensions that we require to do mobility in a raw environment. So the table of contents of the document is what I show in the slide. So basically we have first kind of the definition or the specification of the signaling flow for mobile node control mobility and for network control mobility are very similar, just basically the trigger what changes. And then we specify the mobile IPv6 new extensions, a couple of new messages, and 3 new mobility options. And that's basically it. For the current version of the draft only describes the UE or the mobile node control mobility, but the network control will be described in the next revision of the document. So this is basically a simple scenario from of application. So we have a raw network, and you can see there are some nodes, and you can see that each node may have collocated a PSC, a path selection engine. That's one way of doing it. There may be also a centralized PSC instead of a distributed PSC per raw node. As you can see, raw nodes are wireless nodes that are that form a network where we want to ensure reliability and availability. So this is kind of a wireless dead net kind of a scenario. And we also have a PCE, a path computational element, that is basically computing the paths between the different nodes, and then the PSC, the path selection engine, is taking the decisions on a per packet basis and a very much faster pace to basically get the reliability and availability required by an application. And we have a mobile node there, a UE, that is moving and is attaching or changing the point of attachment from one raw node to another raw node. And then maybe an external destination, in this case, a XR server. This is just an example of application, but any other type of application will also be supported or can be supported. So very quickly, this is the scenario that we define in the draft for UE control mobility. So we have a UE, a mobile node on the left-hand side that is attached to a raw node, the old point of attachment. There is a new point of attachment, so basically a candidate point of attachment where the mobile node will move, and there may be other raw nodes in the network. Of course, the PCE, and then the external node, the correspondent node, we can call it, that in this case is an XR server. So there may be an optional step where the mobile node may be getting information from the potential candidates point of attachment that can be used to take the decision where to attach to. This is optional, and we included in the document some examples of why this may be useful for the mobile node to aid taking the decision. Then at some point of time, the mobile node decides to attach to the new point of attachment, to the NPOA, and upon this, it will send a message to the current, to the old point of attachment, a message that is a raw handover indication. So this is very much based on fast handovers, existing solutions for mobile IP. And this message will include information for the old POA to basically communicate with the new POA and prepare for the handover, basically prepare the network. And in the specific case of RAW, that involves this step number 3, route track computation, where you need to communicate with the PCE, get the paths available from the new POA to the destination raw node to get to the corresponding node. And once that is obtained, we can signal back from the new POA to the old POA with the raw HO ACK, and then that is signaled back to the mobile node, so the mobile node can actually start doing the layer 2 handover to the new POA. In our document, we also make optional to start at this point by casting to ensure to maximize the reliability of the packet delivery. And then in parallel, there will be the raw signaling, raw specific signaling that may happen between the PSCs to basically ensure that the network will still provide the required level of reliability and availability. And once the mobile node has attached to the new POA, bycasting may stop and we basically finalize the process. So this is an extension of what fast handover kind of type of protocol will require to do in a raw environment. Then we have a network control. I will not go into the details. Just the trigger is what changes from the previous scenario. Then in the document, we define these mobile IPv6 new messages, which are basically or they are based on other solutions that we have in the past, and the new mobility options. I will basically, if you are interested, you can check the details in the draft. And then as next steps, basically we would like to collect feedback from you guys, from the DMM working group as the experts on mobility. And we will be presenting this in RAW, which is kind of the hosting, or could be the hosting working group for this type of document during the week. And basically, I just wanted to get feedback and ask you if you can provide comments now or better offline or through the mail list. And that's it. Thank you. Thank you very much.
Thank you, Carlos. Any comment, feedback to Carlos? Okay. Please read the document and make the feedback to the Carlos, online, offline.
Thanks.
Thank you. So we went through the whole agenda today. So thank you very much. See you in San Francisco. Applause.
Excuse me. Muy bien. Muy bien. Okay. Yeah, a few minutes. I need to talk to you about, because I did schedule a meeting. I did schedule dinner tomorrow. Yeah. Can you help book the rest? So I've already sent them. We have to do it tomorrow. Otherwise, we lose. Can you look at the last day? I see you. Thanks. I understand that you meant to go with it. It's the same restaurant. I lost. Something.